Hi, everyone. Thank you for joining us today in our third session of the Open Buildings Designer live series. If you're joining us for the first time here, let me quickly introduce Open Buildings Designer. It's Bentley's Building Information Modeling or BIM tool for the different disciplines that go into a building: architectural, structural, mechanical, electrical, plumbing. The live series is accompanied by a free 21-day trial of the Open Buildings Designer software, or OBD as we call it, so that the users get a chance to try out what we show in our demos. You can download your free trial by scanning the QR code in the top right corner of the window. There will be tips and tricks, user case studies along with it to ensure you gain the most during the trial period. I'm Meenakshi, your host for today, and I'm a product consultant for Open Buildings Designer. I'm based out of Singapore and have worked in the AEC industry for more than a decade. Joining me is our main presenter, Jin Lingyo, and our backup presenter for today, Kashia. Jinling is a user success manager with Bentley Systems. She's also based out of Singapore, specializing in Open Buildings Designer, generative components. That's our focus for today. Since June 2018, she has led many OBD user training sessions and provided professional services to users both locally and internationally. Kasia is based out of Poland. She's an architect with international experience in design. Joining Bentley as a building application engineer, she focuses on functionalities of OBD as well. She provides support and training to users. Kasia will also be able to help us answer some of the questions or comments posted over LinkedIn today. So please go ahead and put in your questions, if any, in the comments section below. And here are email IDs. Feel free to email us and ask your questions or share more about your current BIM projects and challenges with us. We'd love to hear from you. You see a QR code on the top right of the corner of the window. In case you have trouble scanning the QR code, here's a larger one. Scan to download your free trial. Like I mentioned, you will also receive tips and tricks in your inbox, so look out for those. Our previous two sessions are available on LinkedIn and YouTube, where we demonstrated creating a BIM model of a building from scratch and introduced the basics of object-based modeling tools, extracting schedules and reports from the BIM model. Today's session is personally the most interesting subject to me. It touches upon computational design and introduces Bentley's tool for computational design, generative components. So what is computational design? It's as simple as tapping into the ability of computers to calculate and perform multiple complicated tasks simultaneously. The AC industry has moved successfully from hand drafting to CAD to BIM. However, computational design, it remains a largely unexplored territory for most architects and building engineers. They have different strengths and may not have the time or inclination to learn how to code. Computational design tools deliver the power of these processes with visual programming, which Jinling will demonstrate in a bit. It involves a shift in design thinking and methods, almost advancing from drawing geometry to generating geometry through authored computational processes. It can be used not just for complex geometry, which look like spaceship, but also for simplifying your day-to-day processes, freeing up more drawing time of the designers to explore, assess, and optimize the generated designs for better performance. Some fairly simple examples, which we often, some images we often see over the internet, are, quickly testing out different proportions of a building model with height, depth, length as parameters, or twisting the floor plates as your buildings go up. Those are fairly common examples that we come across, or changing the facade grid, for example. Different ways of computational design can influence the way buildings are designed. Exploring multiple design options is one of them, and through parameters and constraints, defining the relationship rules between the different AEC elements, automating the repetitive tasks, incorporating computational design tools makes it easier to test variations at the design stage itself, and thinking algorithmically. This is an example how the program is assembled graphically, the one you look at in the gray block. That's how it's assembled graphically rather than blocks of code. What we understand in scripting is mostly like a lot of code, but this is how it's done in a visual programming. And today's session, Jinling will touch upon the basic concepts and interface of generating generative components that is now a companion application with the BIM tool Open Buildings Designer. She will demonstrate exploring design alternatives using parameters and creating custom nodes in generative components, or GC, and reusing these in other projects as well. So let me hand over to Jinling. But before that, Jinling, can you share with us a little more about your experience with generative components and how you got interested in it.
Thank you, Minashi. So, first of all, hi to everyone. My name is Jingling, User Success Manager in Virtuosity. So, basically, today we'll touch on generative component, which is what Minashi has already mentioned. And basically, how I started off is I wanted to explore different ways in terms of modeling. So, computational design is actually an interesting way to start off in terms of finding different design options in terms of your model. So I have helped out with some of the user in terms of things like creating models, which involve large infrastructure projects using generative component, as well as some of the building rail road models using generative component. So it really helps to automate some of the elements that you are creating, which you can easily model using computational design.
So, can you introduce us to the basic concepts and interface of generative components in very layman terms?
Yes, sure. I will start off with showing you the basics of how generative component works. So as you can see from your screen now, this is how generative component works. In whichever software you open, whether it's in OpenBuildings or other Bentley tool, which has generative component as a companion feature. So once you open up the computational design feature that we have, which is generative component, you'll see an interface which is something like this. So same interface, you will see ribbon interface as well as this modeling workspace. It's just that you have additional things at the side. So one of the thing is this node type at the left of your screen. So this is where it will help us to create models by using all these nodes. So this node is something like some of the feature that you use modeling back in normal open buildings using all these icons at the top. It's just that now we are using this node so that we can create something like a visual diagramming by dragging all these nodes into our graph. So graph is where we start building up our script. So in terms of modeling in computational design, we are modeling using the graph. So this view that you see in here, which is this view one, is just to show you the graphic of how your model looks like when you have finished creating it using the graph. Okay, so just to show you how generative component work or how computational design works. So I'll start off by showing you how you can create a simple model out of it. So to start off with modeling using generative component, first you need to let the program know where you're starting, because as I said earlier, modeling is through the graph, and since it's empty now, the program does not know where you are starting from. So basically, you just need to create a coordinate, which is this XY coordinate that you see in here in my view. So we just need to let the program know that we are starting using this coordinate here. So this is just the project coordinate, which is the 000. So to start off, you can just place this, which is create base CS. So at the top here, under the ribbon interface, there is this place geometry tool here where you can create simple thing like placing a point, placing some of the lines, which is polyline, B-spline curve, as well as creating shapes, which is using polygon. So in this case here, I'm going to create a base coordinate system, which is basically telling the program that I am starting from my 000 point. So I'm just going to click on it and just choose design model. Basically, this design model is just saying that I'm modeling using this view here. Okay, so once I do that, you'll see that I have a node popping up in my graph. Okay, so that's why I say that modeling is done through this graph, because every time you place something in the view, automatically you will see the model appearing in your view. You will also see a node popping up in the graph. So this is the base coordinate that we have created, which is just telling us that it is starting from this 000 point here. So once you have a starting point, you can basically start creating whatever elements or shapes that you want in this view one here. So I'm just going to start off by creating a simple rectangle, then maybe creating extruding it into a solid to create something like a panel or window frame, which you can use it for facade use. So to start off with that basic creation, all you need to do is to create the polygon, which is the shape of how you want your panel to be like, then extrude it. So it's the same concept of how you do in modeling. It's just that in computational design, you have to break it down into smaller steps, meaning you have to place the point, then create the polygon, then extrude. Okay, so to create a polygon, you can either use it from our node type. So if I were to just zoom in quickly, you can use tools like points, then you can create it into a polygon. If not, another option is back in our ribbon interface, we have it under place geometry. There is a tool which is polygon. So I am just gonna use this polygon node to help us create. So once I click on it, and I will just bring my mouse over to my view one, you'll see that I have this coordinate following my cursor. So this coordinate is just telling you that it is creating a point on your view, and this point is to help us create our polygon shape. So I'll just place 4 points, so 1, 2, 3, and 4 here. So while I do this action, you'll see that even though I start placing it in my view, automatically nodes will start popping up in my graph. So these are the 4 points that I have placed earlier on, and automatically it generates a polygon node for me, which is this rectangle here in my view one. So everything is linked together. Whatever you model in your graph will appear graphically in view one, and whatever you place it using the tools under place geometry, automatically node will be appearing in your graph. Okay, so once you have this done, if you want to manipulate all these points, you can easily move it by using our move tool back in our ribbon interface. You can click on move, hold on to one of the point, you can freely move it around. Or let's say if you have a specific dimension you want to give, you can key in those values in those nodes here. So each node represents 1 point. So you can actually key in the X, Y, Z value, which is the dimension from here. Okay, so once we have the shape out, which is this polygon, we can easily create a frame, which is extruding it from this curve here. Okay, so how we can do it, we can just go into our solid node. So since we are extruding it to a solid, so that we can use it for our panel, I'm just going to bring out this solid node. And if I were to zoom in into this node, you will see that there are different things. So the first drop down that you see here, it is the node technique. So I'll just click on it just to show you what is in here. So basically, it's just showing you the techniques of how you can create a solid. Okay, so all this technique here that you see is broken down into a different ways of creating this solid. But if you want to refer it back to OpenBuildings, it is just the different options that you see in the interface just to create a solid. So it's the same concept, it's just that now we have to create it in this manner here. So I'm just gonna choose the one that says sweep profile along path. And you'll see that there's two arrows here. So the one on the left is an input port, which you are giving in values to create the solid. The one on the right, which is the output, is basically the properties. So whatever properties that you create out of this solid, it is just showing you in this output here. Okay, so I'm just gonna go into this input. I will bring out some of the options, which is things like profile mode, the dimension of it. So I'm just going to create a rectangle profile along this polygon here. So that's why I bring out this profile mode so that I can change this to just creating a rectangle. Then from here, I can choose my dimension that I want it to be. So I'm just going to say it is around 50 mm. So once I've set all this, all I need to do, or the last thing I have to do is to tell them where do I want to create it, which is this path here. So all I need to do is to link this polygon into this path here. I'm just going to link this into the path. So once it's done, if I were to come back into my view one, you will be able to see a rectangle profile extruding from the side. Okay, so just so that you can see it clearly, I'll just turn off this visibility so that you can only see the frame that was created. So basically this frame, which has all these properties being created from this node here. Okay, so to continue on, so let's say if I want some frames coming up from the side, you can also do that by having control points along this polygon that we have created earlier on and extrude it. So it's the similar steps, it's just that in this case now you'll have to have control points at the side, then extrude it along. Okay, so just to show you quickly how it works, I'll just go into my node type under point, just drag one of it out. Same thing, I'll need to look through the techniques on what I want to use in order to place it. So I'm just gonna use the one that states perimeter along curve. So this allows me to choose the curve that I want to use, which is this polygon, as well as where do I want it to be. Okay, so this curve here, I'm gonna choose this polygon, but I'm gonna get help from some of these properties here, which is this control point. I'll just zoom in so that you can see it clearly. So I'm gonna use one of this property to help me, which is control point, control polygon. I'm just gonna connect this into this curve. But just take note that because this curve here, if I were to just select this, the entire polygon, they will calculate only, or they will only place one point along this entire perimeter of this polygon. But if let's say I want it to be it in individual lines, I can add additional things behind by stating that I want to extract the line segment. Okay, so I'm just gonna extract this line segment here. And let's say I want to place it in the center. I put 0.5 because they consider it as the line as 1. So 0.5 is basically half of the line. So once this is done, if I were to just highlight it so that you can see it in this view, you'll see that I have 4 points created here. So once I have this, all I need to do is to just create lines connecting from one end to the other and plug in into this solid to same thing create this frame here that we have created earlier on. So just drag this to the side first. I'm going to bring out a line node. Same thing, go back into your node type to find it. Under geometry, you should be able to locate a line. I'm just going to use the default one, which is having our start point and end point. So start point, I'm just going to use one of the points here. So if you can't select it, what you can do is to just temporarily off this visibility so that you can easily select the point. So I'm just going to quickly off the visibility of this. Coming back into my start point, I'm going to select this point here as well as this point here. So basically, I'm just connecting the top to the bottom, the left to the right. So my start point will be this 2 points, and my end point will be the other two. So it will be this point here, which is the bottom one, and the next one is the one on left. Okay, so basically by doing this, you'll be able to connect it easily using just one node. So if you're confused on how you connect it, you can have two separate nodes, which is line. Then you can connect one point to this first, then the other node to connect the left to the right. So it doesn't matter. It's just the process of how you understand and how you can easily create these lines from here. So once I have this, let me just turn this back on so that you can see the outcome later on. So once I have this line created, same thing, this is like a path to create the solid. All I need to do is to just connect this to the path. So let me just zoom in quickly just to show you the end result. So basically it will extract another solid onto these lines here. So you can have multiple values in one of the node. It doesn't matter because you can actually easily replicate things from one node itself. So you can have many values as long as it fulfills the requirement, they will create the models for you. So basically this is how you can easily create geometries out of generative component. So I hope it covers the basic of how generative component works.
Sure. So, can we use this panel that you just created to model a building facade?
Yep. So as I mentioned earlier, this can be one of the building facade. So since you'll be saying that I have already create, so let's say I have already created a panel in this DGN here, but I have a building in a separate model or a separate DGN. So how can I bring this over? Do I have to create the building in here again? Or can I somehow bring this panel over? Okay, so there is a way to do it. You can either import this into that DGN file, or you can create something like a generated node type. So creating a generated node type is basically creating one of these node here that you see under node type. Okay, so I'll just quickly scroll down just to show you. So in this node type here, there is a few category. So one is geometry, which I've been using just now to explain how you can create simple shapes out of it. So there is a portion which is generated. So all this is basically you are creating a certain shape or a certain model that you want to use for your other project so that you can easily use it as a node like this to place it. So you can generate a node out of this model here, which I'm going to show you later on. Then there is also a category which is open buildings, which is nodes, which includes things like doors, creating walls, creating some of the plans or structural components out of here. So all this is actually available in our Open Buildings Designer catalog. So lastly is just utilities, which is things like exporting your file, bringing in through Excel, or creating notes from here. Okay, so going back into creating generated node, so how can we create this? So if we were to zoom in into our back into our ribbon interface, so under primary, we have this thing called generate node type. So we can utilize this to create one of these nodes so that if we open back our building model, we can actually use this node to place our panel. Okay, so I'm just gonna quickly click on this. It will show you this dialog on how to create a generated node. So from here, you'll see that there is two portions here. The first one is the input. The second one is the output. So basically, this is just telling you that input means what are the values you want to give in to create the model. The output is basically the end result of what you want to create. Okay, so in this case, you can actually select from your GC model. So what it means is once you have created the shape using generative component, you can actually select from all these nodes here to help you generate this new node for you. So just to show you how it works, first of all, I'm just going to select the output. So I'm just going to say select from GC model. You can come back into your graph and select the node that you want as the output. So let's say I want it to create this frame here, which is this solid. So that's why I select this. And once you have select this, you'll see that automatically input, they will give you values which help you create this solid here. So basically you will need a polygon as well as a line. So let's say if you want some of this input to be optional, you can actually check this so that when you're using this node, all you need to do is to connect a polygon, which is a shape, and automatically it will generate this solid here. Okay, so there is also other options. So I'll just zoom in so that you can see clearly. So there is things like replicable. So if you want to have a replicable polygon, so let's say if you're using this for building, usually you will want it to be able to place it in multiple polygons so that you don't need to place it one by one. So you can actually have this check so that later on you can just place one node and have multiple elements being placed from here. Okay, so once you have this done, if you were to look at this bottom here, you have a choice on whether you want to store this new generated node in your GC environment. So what this means is that whenever I create a new DGN file or just opening up a separate DGN file, I want to see this generated node type so that I can use it. So you can check this box so that it will automatically appear in all your DGN. So you don't really need to always create this node again and again just to use it. You can just check this and it will be available in every DGN that you have generated. Okay, so once all this is done, just give a name to your node and you can just click on OK and automatically it will start generating this. And you should be able to see under the generated category back in your node type. So basically this is how you can easily create the panels or any facade that you want to create in generative component. Put it into a generated node type so that you can bring this over to a new DGN which have your model or your building in it and easily place this instead of creating this long script again in a separate DGN which have your building in it. Yep. So
Okay.
I hope it answers that question.
Yeah, yeah, sure. So can you show us how to insert this panel in a building?
Oh, yep. So let me just bring a sample out that I have prepared here. So I'm gonna use this example here, which is this Lizo Suho. So for those of you who are not sure of what this is basically a skyscraper in Beijing, China. So I'm gonna use this example to show you how you can easily place this panel into this building here. Okay, so first of all, I will have this panel already created in a separate file. And this panel, I have created three different options so that I can explore the different types or I can actually place the different types of facade that I want on my building. Okay, so this is the first one. Same thing, the same process of creating a polygon, placing some of the points for this control, then placing or extruding it to a frame. Okay, so after I do that, I can just generate it into one of the node. I can explore the second option. So I can have a different type of frame. Same thing, I can place it into a node type. So just to show you, I have a few here. So I can actually create each individual pattern as one of the node so that later on I can use it back in my building. So I have three options here created. So this is the third option. Same thing after I've created this, I will put it into a generated node type. Okay, so once I have this created in a separate file and I have generated those nodes, I can easily go back into my building model. So I'm just going to bring this out. So same thing, I'll just quickly go through how you can create a building so that everyone knows how you can easily set this up using generative component. So same thing, I'll need a base coordinate system, which is the starting point. I'll place some of the floors here, which can be run through using our slider, which is located in our utilities back in our node type. Setting things like the floor to floor height using a slider so that I can easily change it. And attaching all these values into a plane, which will help us create something like this back in our view or our design model here. So this is just setting up the different floors that we have for our building. After which you can start setting up the shape that you want your building to be. So just to quickly show you how you can set this up, you can use one of the utilities here, which is law curve. So let me just click on it just to show you how it looks like. So you can actually control the shape of the building, of how you want it to be like. So in this case, I'm just going to create a simple curve. And you can just easily connect this shape into this profile here, which help us create this curve that you see on our building. Okay, so I have different law curves here, or different types of shapes on how my building is curving, because I want to set up as maybe the left side to be in this shape, curving in this shape. Then maybe on the right side, I want it to curve the other way around. So you can actually easily do this by setting up the different shapes you want it to follow and just connect it into this profile here to have these different shapes here. Okay, so after I have this, all I need to do is to just set up the polygons that will be on this profile or on the exterior of this model here. Okay, so first of all, I'm just going to separate it into different shapes. So I'm just separating this model into different segments so that I can place different type of panel on different surfaces of this building here. Okay, so what you can see here is I have this graph already set up. All I'm doing now is actually just playing this transaction. Okay, so basically this transaction is saving all these steps that I've done in this graph here. Okay, so I can actually trace back if I want to see a certain steps that I did, or I can actually start playing the transaction and automatically they will populate whatever node that I've used to create these steps that I've saved here. Okay, so just to zoom in, just to show you, I'm starting to create these few shapes or this polygon into different surfaces or different levels on this building. So later on, I can actually place those different panels onto these few polygons here that I've created by using this node type here. So all this that I've created just now, using the previous DGN file, which is the panel, I'm going to place all these nodes onto these surfaces here. So I'm just going to go back into my transaction. Let me just close this first. I do not need this. I'm going to start adding those profiles. So I'm just going to add everything on. And if I were to zoom in, so basically this is where I'm going to place my panels in it. So you'll see that it's a different naming. So just now it is things like creating line, polygon, circle, or surfaces. So now this is the name that I give for my generated node. So all I need to do is to connect these few polygons that I have into this. So automatically they will place the panel in. Okay, so let me just look for it. So all these points here is to create the building. And all I need to do is to bring out some of this. So I have some of this prepared, so I'll show you here. So this is using the basic shape, which is arc, to create some of this building here that you see. So let me just bring this out to show you this. So you can actually place those different panels. So I have already placed it, so you'll see that I can actually indicate that this can be one type, this can be the other, and this can be the third panel. So those are those three options that I've created just now, and I've placed it in these different surfaces here. So this can be easily done. So if let's say you want it to be the same, you can just quickly change it so that automatically I can have the same panels as the rest. So I'm just separating this view into different panels just to show you that you can actually separate up or you can actually arrange even though you have different design options or if you have different types of model and you can actually easily segregate this view. So this is how you can easily place the nodes that you have created into this model here.
Okay. Okay, so
Yeah.
I see we can differentiate the different sizes or the different specifications of the panels graphically.
Yes. Okay, so the one I showed you earlier, yes, you can. So the one I show you here. So after placing it, right, if you want to see it graphically or on the difference, so if you zoom out, it is quite confusing. So maybe if you pass it to someone else or another user to do it, they may not know which segment is using the panel. So one option is to just go to the node that is controlling it, click on it, automatically they will show you. The other way, you can actually control it through Excel. So the one I've shown here is actually controlling through Excel here. So let me just quickly bring up this Excel here. Okay, so sometimes controlling using Excel is much easier because you can actually change the values here and automatically it will also affect my model back in generative component. Okay, so I can set up things like the levels indicating my building, and I can also set up what are the different type of panel I want to use. So maybe let's say this portion, I set it as 2. So some of this in blue is 1 and the rest of this is 3. So basically all this number is actually represent a different type of panel. So it's basically the different types of panel I want to use. So if let's say I want to change this, so instead of this following the third option, maybe I want to change it to 1. You can actually change it in Excel. Just save this, come back into generative component, you can just click on update model back into the ribbon interface. Okay, so why will it automatically change is because we are using this node here, which is this Excel range. So this is actually controlling this value here. So let's say if you want it to have a separate panel just to show it graphically on how it looks like in the model, you can actually change the value back in Excel, just save the Excel and come back into generative component to update it, and automatically this will change and automatically it will update how it looks like graphically in this design model here. So yes, you can easily change it if you want using Excel, which is a very easy option here to change values.
Yeah, that's great and very helpful if you're sharing it with consultants and stuff. So that really helps. Okay, so we shared some cool images over LinkedIn of the different iconic building structures that may use generative components. Do you want to share that with us?
Okay, so let me just bring out a few. So first of all, let me just start off with this Liwa Tower here, just so that everyone know what this is. It is a skyscraper in, located in United Arab. So you can use this. This is the same concept as I showed earlier on, which is creating these few panels. So the panel that you see here, same thing, it is using a generated node type, which is this node here, to create this model. So same thing, it is being controlled by the polygons that is already created on the building, which is these two nodes here. Okay, so same thing, if I were to go back the process to create this polygon, I will just need the control points on the surface of the building, and automatically I can create the polygon and place my panel, which is the one that I have already generated out under my generated node type. So if I want to change the different design, you can either change it by having a different node type which have the different patterns in it, or let's say if you have dimensions, or let's say the size of how this looks like already indicated in your node, you can easily change the dimension back in this node under the input here. So this is just another design of how you can do it, but similar process of how you place it. It's just that maybe some of the technique is different in terms of how you place the polygon or how you create the building. Okay, so to show you the other way of creating this building, I'm just gonna bring out this model here, which is this absolute tower. So this absolute tower here is actually a condominium in Canada, so that you guys know how it looks like. So in this here, we have this twisted structure here. You can actually control it using the points. So same thing, everything can be controlled to the points, then you create the shape. So here in this case, I'm controlling through a coordinate system. Same thing, it's just a point. And here I can actually set up how I want it to be twisting along. So same thing, this I can set up according to my floor to floor height as well as the amount of floors I have using the sliders, and setting up how I want to twist it, and automatically they will generate this profile as well as it twisting while it creates this model here. Okay, so same thing after I've created, all I need to do is to set up some of the things, which is things like the line, then setting up the surface, then after which creating the solid or creating this polygon to help us place the panel. Okay, so it's always the same. You will create a polygon, then start bringing in our different design for our facade. So you can either create it from scratch by just creating another script here and connecting to this polygon, or if you have it in the generator node type, you can just automatically connect to the generated node type. Okay, so just to make it clear, you can also create a panel here. The reason for us using the generated node type is so that we can string the amount of scripts that we need to create this model, as well as if we were to create it into a generator node type, all we need to do is to have one node. We can actually control the entire panel on how it looks like on our facade. Okay, so that is some of the advantage if you were to use the generated node type. Okay, so just to show you another model, which is this stadium here, which is located in Beijing in China as well. So this here is quite straightforward. So you don't really need a generator node type. All you need to do is to create this surface, then placing all this structure onto this surface here. Okay, so same thing in this case here, I'm gonna create the surface. So I have created the surface. After which to place all this structure here, you can actually use some of the techniques, which is first of all, I'm just gonna rotate this model. I can actually create the lines first flat on the surface, after which I can project all these lines onto this curve so that it is running randomly onto this surface to create this structure here that you see. So just to show you how it's being created, so basically I have these lines. So if I were to just highlight so that you know which one I'm indicating. So I have these lines already created flat on the surface as you can see here. So this is running randomly connecting from one end to the other. So after I have that, all I need to do is to project it into my surface that I've created, which is this surface here. So I can just project all this onto this surface and automatically it will run randomly onto my surface. Okay, so after I have all this path being set up, all I need to do is to just extrude it. So same thing I use here, sweep profile along path. After having the path, which is all these lines that I have project, automatically I can create this to create this structure here. Okay, so if you do not want to see the lines in the end product, you can just turn off the visibility, so it's fine. So basically this is some of the models that I have prepared. So these are some of the techniques that you use, but the process is usually the same. It's just that the technique that you use to create the building, it differs from, it depends on the type as well as the shape and structure of the building. Then from there, you choose the different technique to create the model, then placing the panel or the facade that you have created, either from the generator node type or just extruding it from a simple solid. So that is all I have prepared for you for this model here.
Okay, great. So, so the generated nodes that you're mentioning, so do we have to start them from scratch for every new project or building, or are we able to reuse or recycle the scripts for these?
Okay, so if I get you correctly, there is maybe two things in there. So first thing is this generated node type. So if, as I've mentioned earlier on, when you are creating this node, if you were to have this set up properly by having it stored in your GC environment, you can actually, it is actually available whenever you create a new DGN. So you can actually use this node. So if let's say it is using a similar panel, it's just that the dimension maybe it differs. You can actually use this As long as you have this check when you're creating the node, it will be available whenever you create a new DGN file. Okay, so the second thing that you talk about is the script. So just now I've briefly ran through this transaction here. So this transaction is saving all these steps that we have done in this graph here. So as you see just now, I'm playing this transaction. So while playing this transaction, automatically I have the graphic as well as this node appearing in my graph. Okay, so it is similar to how we save the model in our DGN. It's just that this transaction is saving it, which is saving all these steps that I've done in this graph here. Okay, so all this here is actually creating a script out of it. So even though it is saving here like this, it has a script behind this. Okay, so where can I find it? I'll just zoom in quickly. So it is actually in this icon here, which is the editor. So if I were to just click on it, they will bring me this editor dialog here. Okay, so basically this is all the scripts that is saved in this transaction here. And from here, there is actually a file that is being saved out of it, which has the file extension .gct file. So you can actually find it together with the DGN that you have saved to. So all you need to do is to copy this transaction and copy it into a new DGN file. So let me quickly just show you. I'm just going to copy this. And let me just bring out the empty one that we have used just now, which is this. I'm just going to overwrite this. So I can just open this editor. I'm just going to remove everything and I can actually place the script in here. Let's say apply. And automatically you will see that if you look into our transaction, they will list down the same thing, all the steps that we have did just now to create the stadium earlier on. Okay, so you'll see the exact same thing. It's just that now all this, let me just zoom in. So all this is in black because I have not played the transaction. You can just play it one by one or you can just run everything through and it will same thing produce the model. So let's say if you have similar design, maybe it's just the different type of building structure that you need to change, as well as maybe some of the panel design or the facade that you may change, but the steps is the same. You can actually reuse it, just change the type of profile that you're using, as well as changing the facade or the panels that you're using, and you can actually reuse the script easily from here. Yep. So
Okay.
I hope it answers that questions on how
Yeah.
you can actually easily reuse the script that you have created.
Yeah, that's great. That's one of the advantages, I guess, of computational design itself, that you don't have to do it again and again. So that's great.
Yep.
So in our last session, Jinling, we had spoken about with Ramao, we had spoken about the object-oriented tools and scheduling within Open Buildings Designer. Making taking advantage of all the smart and intelligent features of Open Building Designer. Now the generative
Yep.
components is available within Open Building Designer. Does this mean that you can that it can be used to automate the tasks and create reports for all the different variations that you create, like what we are talking about? Is Does that mean that all the intelligent objects can have these different variations as well?
Okay, so if you're talking about report creation, so
Yeah.
whatever things or elements that you have created in generative component, you can actually attach a catalog to it, which is actually an Open Buildings Designer catalog.
Mhm.
So let me just quickly bring it up to show you. So there is an option under input, which is catalog item. So you can actually attach the catalog to it. So once you attach the catalog, so this catalog is basically just Open Buildings catalog, if you're wondering what this is. So you can actually attach it. So once you have attached it, all you need to do is to just go back into the building design workflow.
Mhm.
Let me just zoom in. So in this workflow, even though I open it using Open Buildings Generative Component, I also have the other feature, which is the Open Buildings Designer feature. So I can actually go back into my building design, which has the data and reporting there.
Okay.
So I can easily change this and I can actually create a report from here. So as long as I have a catalog attached to these elements that I've created, I can actually utilize the tools here to generate a schedule. Since now generative component is inside OpenBuildings, yes, you can easily achieve these reports from these tools here.
Okay, that's great. Okay, is there anything else? We are running out of time. We just have about 10 minutes. Is there anything else you want to share? Otherwise, we'll move to just talking about the questions that have come up.
Yep, I think that is more or less of what I want to talk about on how you can easily achieve some of the models and as well as creating a few different design options easily using generative component.
Okay, great. So that was a great crash course and very fascinating to look at all the cool geometry there. So going back to this, so I just want to introduce everybody to some of the resources that we have on the internet. Like, firstly, we will be posting a YouTube video of this LinkedIn Live as well, and we'll share the link over LinkedIn. So we will take your questions in a bit, but before that, just I just want to share the some of the high quality learning content for Open Buildings Designer. We have a couple of webinars focused on our. You can see the link here on the Virtuosity website. We have some webinars that are focused, like generative components for linear infrastructure like rail, for architectural design, civil engineering. If you click on the link, you'll be able to find it. And we also have a YouTube channel which is dedicated to Open Buildings Designer. And do look at the comments. We have some of the resources, some of the you can just look through some of the tutorials there posted by Eduardo and Stuart. They posted some of the tutorials there. Do look at that as well. And taking some of the questions very quickly. I'm just going to show the questions, and I think the questions have mostly been answered. And sorry about the blurry video. It's to do with the broadband for either in Singapore or in Poland where Kasia is, or it's at your end. So I believe it's clear in United States, and even in Poland it's clearer. So sorry about that. There's a question here we have from Kamal. Is it possible to use in project wise platform? So Stuart has just answered that very quickly. Yes, generative components is one of the design applications that integrates with project wise like any of the design applications, and we'll be happy to send you links for that. Kamal, if you have any questions on that, please reach out via email and we'll be happy to send you more information on that. And Eduardo's answered that as well. You will need to have the workspace managed in project wise for the best results, and that's how you can use it, and we will send you more information on that. And Kashia has shared some of the links, so you can look through some of the links. We don't have too many questions today. If there's anything, please reach out to us by email, and I can share the email address. That's our email for us. So please reach out if you have anything. And please join us for our session 4 of the series on 29th of September. It's at 3 p.m. Singapore time, same time. We'll talk about freedom for design, anything, especially during the form exploration stage of concept design, and the different modeling tool sets within Open Buildings Designer. That makes it what we've been calling it the all-in-one tool. So that will truly demonstrate like how you can carry it right from concept stage all the way to your construction stage, and from 2D CAD to parametric modeling. We'll be posting the link to the next event soon, so please join us for that as well. Thank you, everyone, and we will post the YouTube video link on our LinkedIn page, event page for this. Thank you for joining us today. Thank you,
Thank
Jinming.
you.
Thanks. Bye
Thank
bye.
you.
Thank you.
Bye.
Bye.